Good day. Today, we are very excited to give the high-level overview of our web platform prototype. We will discuss the technical perspective and architecture of our web application. Our front end is powered by React. This is a platform developed and maintained by Facebook. It is one of the most popular platforms that powers most of the modern websites in the internet today. We also use several technologies to make our application more solid and robust. For example, we use MOBX, which is an advanced model-driven state management platform. We also use API It is based on AXIOS HTTP library that enhance with standardized error and request response transform mechanism. It is responsible for handling all the API calls to the backend. AXIOS, by the way, is a popular and widely used HTTP client due to its reactive and promise-based approach to HTTP call. We also use Webpack to manage the application bundles and optimize them for production deployment. Basically, we primarily use Yarn to handle the dependency management for all our dependency tools. In our design, we follow the following fundamental principles. That is responsive, which means it allows the application to adapt to any screen size and orientation. Traceable allows visibility of internal application state for faster and easier debugging. And the most important is modular, which means allows our applications to be organized into reusable components and elements. We also use extended libraries to provide powerful and extended functional features to our web application. For example, we have Sass for our styling. That means we can provide a powerful styling engine inside our application. We also have the React Strap, which is basically a React Bootstrap that allows us to control the UI elements from a central controlling components. We have Babel for extended JavaScript functionality. We have DevTools for monitoring the different state of the application. We also have the React Router to manage the component-to-component and page-to-page movement. And we also use several other components in the application. Now, let's take a look at a visual presentation of our design architecture. So for example, this is our main dashboard. So the main dashboard will show the summary of the payment transactions, gift transactions, job transactions, and other transactions that the user have. At the same time, we also have the visual graphical presentation of the quotation cash flow, either by day, monthly, or annually. So part of our design principle is responsive. That means it adapts to any screen size. So for example, if we resize the screen, you will notice that it's still perfectly looking good, but it adjusts according to whatever is the screen orientation. So like if the screen becomes too small, like in the case of a mobile or a tablet, instead of having a four items in a single row, it adjusts to 2x2 configuration. And as soon as it becomes even small, it automatically adjusts to a single column alignment. It adjusts by itself, but still looking good as it is. So that's how we designed the architecture for responsive design. So as soon as the screen also becomes bigger, the screen also automatically adjusts by itself. Okay. And one of the important implementations that we have is what we call the hot reloading. This actually speed up the development time because it allows us to make changes on the fly without even restarting the server, or even we don't even have to refresh the page. So I will give you an example. For example, we have here in the title bar, we have the word dashboard. If in the source code we modify the dashboard to main dashboard, it automatically will update the display without even having to restart or refresh the page. It means this is what we call a hot reloading. We can make changes to the source code and it applies automatically on the page. That will actually save you so much time because you don't have to refresh the page or restart the server. So that is one of the very powerful features. Now let's take a look at another important capability in our architectural design for our web front end, um, is the principle of responsive design. So how does it really looks like? For example, if we go to the messages, so we have this very basic orientation where you have the message summary on the left side, and then you also have the message details on the right side. Now, if you want them to be one over the other on top rather than side by side, you can quickly do that. I will try to demonstrate. So in the source code, we used what we call the grid system for the layouts. I will show you. So for example, if we want the message summary to be on top and then the message details to be down below, you don't even have to write any source code to do that. All you have to do is just implement the grid system attributes. So for example, I can change this one to 12 because 12 is the grid system for reactive design, and I can change this to 12. As you can see, this is now the header is on top and message detail is below. So it automatically relay out itself without even so much code, so much writing. That is how we design the principle. And if I can turn it back, I go back to like 8 by 4, which is a side-by-side configuration. You can see that on the fly, it changes the layout to side-by-side. All you have to do is just pass the correct attributes. Now we use this grid system, like we have here the small, medium, large, and XL to simplify the screen size. That's why if I change the screen size, if I drag this one to smaller screen, you will notice that it automatically adjusts and refit. And then if it's too small, automatically adjusts by itself to be one over the top. So it automatically adjusts by itself. That's the principle behind responsive design. It adapts and adjusts to any screen resolution and even screen orientation. You can see that, see earlier, we have this menu on top. You have the dashboard transaction. But because if we make the screen smaller, the icon now becomes at the center, the logo, and the menu disappear. And we can still access the menu. Like if we make this really, really small, we can still access the menu by clicking on the icon, and you still have your menu here, which you can jump to different screen. Like for example, you can go to the dashboard, or you can go back to the message screen. So that's how we create the responsive design. Now let's take a look at the traceability function that we have implemented in our front-end prototype. So for example, we are now in the main dashboard. Let's go to the blockchain explorer. Here, the blockchain explorer allows you to see the summary of the data that is written to the blockchain. So you have here, like in the historian, you have the kind of transaction. The transaction has stored in a blockchain, date and time, and you can even view the recorded data in the blockchain, something like that. And also we have the summary, like what is the current block number, and summary of the different transactions, as you can see from the blockchain explorer. But one of the features we will try to explore is what we call the traceability option using our development tools. So one of the biggest problems for most developers is to be able to trace the application state. Application state refers to any particular data that resides inside the application. So for example, the data for the grid or the application options inside the applications. It's quite difficult to trace if you don't have the necessary tools. That's why we use the MOBX development tools to monitor all the application state. So I will try to demonstrate that to you. Okay, so now we are connected to the application state. So this allows you to make a visual inspection of all the information. So for example, I have here the name, Alex Ramil Aguel, and it has a balance of 3,979 rotation cash. But if I go inspect the data inside the application, look at the application state, I can go to the store, app state, and you can see that the account is here, and this is also the balance. So I can actually make this as a debugging tool that allows me to double check that the data is correctly displayed in the front end, and I can verify with the data that is stored in the application state. Now I even have the token. I also have the ID and all the other informations. Like if I have some transaction calls or API calls, I can monitor whether this is successful or not by looking at the transaction application state. So this is a very powerful feature. Aside from combining this with the hot reloading, you don't have to refresh any page. Now you can visually inspect every information of the application from within these development tools. So that's why it's very powerful tools for the developers that allows them to develop at a much lesser time. So that means they can actually deliver at a much faster time, and they can debug quickly because they can make the necessary inspection of the application state. Now let's take a look at the Webpack. This is our application bundler. It bundles all the dependency ready for deployment to the production. Webpack offers a lot of feature. Number one, it optimizes your file for deployment to the production server. At the same time, it creates an abstraction layer that hides the internal structure of your application folder. Let's try to take a look at, for example, so here we have this folder structure where you have the slash, we have the asset, we have the components, models, pages, and inside your assets folder, that is where you have your images. So normally, if you use the standard way of developing and deployment, you will have the slash assets, then logo.jpg, for example. But one thing is, if you look at here, let's go to our dashboard. Let's go to the transaction page. This is our transaction page, which is also responsive in design. Now, if you take a look at the logo, if you go to the logo, right click and copy image address, let's open a new tab. Now, one thing you will notice is that instead of having the slash assets slash logo.jpg, it actually generates a hash of the JPEG file. So it creates an abstraction layer to your internal folder structure. Not only it optimizes the file, it compresses the file, it loads on demand the dependency, it also provides an abstraction layer to your folder structure and files. So instead of showing you the logo.jpg, it provides you with abstraction by using the hashing algorithm for the file. Now, if we go back to our internal folder structure, you can see that we can still use the same reference to the file. Like in the header, we have slash asset and slash logo. But once you deploy that in production, it's just referencing to the hash equivalent of this file. Okay, now how do we deploy that? So if you look at here, we already have the script for deployment using Webpack. This is the development mode, and we also have the config for production mode. So it's quite easy to actually do the build for production. So all we have to do is select this. If we do the yarn build command, you will notice that it creates the Webpack config for production, and also we are now in production mode. Now, if you look at that, Webpack actually generates a hash version of all the files and dependency. That's why you cannot see the folder structure, but rather the hash of the file. Okay, so it has completed, and now you can see it's creating a hash of the assets that is required by your application. Okay, so what it does, if we go back to our folder, it actually creates a distribution dist folder that contains your production ready application. That's why you can see here all our hash files, and they are actually optimized for production grade deployment. Okay, so that's how Webpack works, and this is the high level overview of the technology and architecture that we use for our web platform prototype. Thank you very much.